This is a Carboline production.
The cured hardness of an intumescent coating is important for a variety of reasons, depending on where you sit in the contract chain. Rigid specifications often force construction teams into choosing among only a few materials based on their hardness, usually as determined using the Shore-D scale. As we'll discuss in this episode, that's a problem. My colleague Michael Hollman joins me to talk through how to solve it. Well, Michael, thanks for joining us on the Red Bucket today. If you wouldn't mind, before we get started, maybe give us the brief biography. How did you get to where you are today?
Good question. So, straight out of school, I joined the local paint company as a junior technician in R&D, and I was selected to work in the fire protection lab. And actually, that's all I've ever done since then. So I've had 32 years in the industry, working in R&D, developing intumescent fireproof coatings of all different types for different companies as well, most of the market-leading companies, testing and supporting those products into many different countries around the world through the local fire testing standards that are needed for each of those countries. So yeah, it's been quite an interesting career that's taken me to many different countries and continents and meet some interesting people. And so that has brought me to PM and Carboline, where my current position is global product manager, looking after the intumescent fireproofing range. I'm responsible for developing a pipeline of products that meet our current and future needs for the different markets that we want to operate in.
Speaking of all these different countries and continents that you've been to, the country that you are in, if guests didn't already notice your accent, you are where, sir?
So I am English, and I am currently in the miserable north of England, very close to Manchester. It's a great place. It's just the weather is a bit miserable today.
We're recording in the middle of February, where the difference between the weather Michael's having today and the weather that I'm supposed to have here in St. Louis is, I don't know if you couldn't draw it up any different than what we'll have. So there's one big idea with this whole episode, Michael, regarding hardness of intumescent materials. What's the big idea?
So the idea is that the Shore-D hardness of an intumescent material or coating has zero influence on its performance.
I guess we can stop right there. Thanks for joining the Red Bucket, and we'll be back next time with another great guest. So what do we mean by hardness? For those who might not be familiar with what it is or why in this context that it matters.
So what we mean by this, the hardness, is typically the extent of cure or drying of a coating. So it's a physical measure that we can look against and have an absolute number that will actually tell us when the coating is either chemically reacted or physically dried to the level that it's not going to progress any further beyond that.
Has measuring its hardness always been the way that we understood how well cured or how finished a coating is?
No, it hasn't. So this is where it has always been common practice in the hydrocarbon industry, where you've got thick epoxy coatings, and it's part A and part B are mixed, and you can measure the hardness as an indication of when it's fully reacted. And then it's ready to be put into service. But what we're seeing now is that it's actually going beyond that market and that technology, and it's just becoming a blanket term now for use with all intumescent coatings, regardless of the technology or the market, really.
So you've seen that gradual adoption over your 32 years then, or does that predate your entry to the business?
Over the time that I've been in the industry, at the early years, it was limited to one particular area, but then we are seeing more and more where it's getting adopted in other markets where it's not really relevant. So as I said earlier, that it has typically been used where it's epoxies and part A and part B are mixed, and it indicates when the reaction is complete or as complete as it's going to get. But now what we are seeing is it's used in more architectural coatings, whereas it's single pack coatings that are just lacquer dry. And because it is different technology, to use the same scale and the same expectations just aren't appropriate.
Those numbers, those measures need to come from somewhere. So there's, of course, specialty equipment that we use to find that out. Can you tell us what a durometer is? How would you describe that?
So I would describe a durometer as a simple handheld tool that has got a needle of different types loaded onto a spring, and then the spring is connected to a dial. Um, so that would be an analog one. Obviously, we can get digital ones now in today's technology, but with an analog is the simplest and most common one, and then you simply press the needle into the coating until the foot is flat, and then the resistance on the spring will force the dial around and give you a number. So because needles are very different depending upon which type of durometer gauge that you're using, the needle will indent to different degrees. So what we see with very hard coatings, then you use a needle that is extremely sharp. But then with softer coatings, and this can be other materials as well, but it's typically used with coatings, then the needle has got more of a rounded end to it, a bit more of a peened finish rather than a sharp needle point.
There are more than one hardness scales. You mentioned Shore D at the beginning. There are, at least from my reading, there are 12 different scales, and for this discussion, we care about two of them, Shore A and Shore D. So you mentioned the shape of the foot. Which hardness scale gets which shape of the foot? Which one's pointed and which one's blunted?
Okay, so Shore D is the fine needle. And Shore D is used for typically hard materials, very tough materials. And Shore A is a rounded needle on it. It's not really fair to say it's a needle, really, but it would be like the end of a knitting needle or something like that. So it's quite a soft, rounder tip. And this is used for softer coatings. But as you said, there are a lot of others as well. And if you look at the standard, which is ASTM D2240, it will describe the typical coatings that are used or typical materials that can be used and can be tested with each of the different durometers.
Does that standard, among the different coating examples that it states, does it state intumescence as one of the ones? And if it does, which scale does it tend to put it in?
No, it doesn't state intumescence. It will just give typical types of products. So coatings would be in there, of which intumescence would be a subgroup of that. But then there are others where it will typically say foams for measuring the hardness of things like foams, for comparing one against another. Then that is a different particular grade of durometer.
How well do you think this topic, the hardness scales, Shore D, Shore A, how well recognized are these in the minds of the folks interested in intumescence, realizing that, depending on someone's job, they're going to have a different level of awareness?
Yeah, I don't think that they are very well understood, that there are differences in the skills out there. So I think that we have seen some initial specifications that typically were for offshore for determining when a coating is ready to go into service that have been cut and pasted essentially into other markets, other projects, other construction types without the recognition or understanding that maybe that particular part of the specification just isn't relevant to the project or the coatings that are going to be used for the fire protection solution.
Which brings us back to the reason why the Shore D scale is the one that I guess is found the most often in this world, in the world of intumescence, because it was borrowed from somewhere else.
I think that's perfect way of boiling that down, Toby. I think that it was done for an industry that is highly specified with the offshore oil and gas petrochemical industry. And then as the specifications have advanced for different markets, then it's been borrowed without actually checking if it's appropriate and modifying accordingly.
Owners, architects, engineers understand Shore D and understand hardness a little bit differently than a contractor would in the shop or in the field.
The owners, architects, then it's seen as a way of determining that that product is fit for purpose and would be okay in service. So it is hard, it's tough, it's going to be okay for the lifetime of the building. I think for the contractors and things like that, I think we could argue whether it's actually just a tick box exercise that it's on the specification, so it doesn't actually mean that much to them, and they've just got to comply with it. It might be it's seen as a way to differentiate between different products, how good they will be in transporting, so that they're not prone to damage. But ultimately, even if coatings are softer, then we can employ best practices for transporting as well. Because I think that we have two sides to the coin. Generally, hard coatings can be quite brittle, and if there is any damage, then that damage is exacerbated around the area where if there's things like an impact. Whereas if there are softer, more bland coatings, then actually these can absorb any damages more easily and readily, and will be more suitable for transporting. And it's trying to get this across to the contractors that actually just because it's a higher number doesn't mean that it's actually better for any damage resistance or impact resistance.
So, talk about Shore A. We've been talking about Shore D and how it came to us from offshore oil and gas, meant to assess the level of cure for hard epoxies. Talk about Shore A in terms of the actual numbers that you see in a Shore A test. What do those look like, and what do we use A for?
So Shore A is identical to Shore D. It's just with a different shape to the needle. But because you're using it for different technologies as well, and it typically is for softer coatings that might be a bit more elastomeric rather than thermoset coatings, then we typically see different numbers because it's different technologies with a different machine, a different gauge. So one number that is typically used in the industry with Shore D is this figure of 70. Now that is measured on one product at one time and has been in specifications for all different types of technologies for a long, long time. It doesn't mean that other products won't work if they don't hit that mythical number of 70. But with Sure A, because we are looking at different technologies with a different gauge and a different machine, then the number really needs to be derived from the products that you're measuring. So for those specific ones, so typically for one of our products, then we would see this. We would typically get figures of around about 40, and this doesn't mean that it's any worse than an epoxy measured with Sure D. It's just a different technology measured by a different machine. In the approval processes that we have to do with fire protection materials, before we can sell a single gallon into the market, we have to verify that they perform and are fit for purpose to third parties. And part of that approval process, there is hardness testing does not come into it anywhere. Okay, we check it for fire and make sure that it is going to work when it needs to work and for the amount of time that we're expecting it to. And we also check it for weather resistance, so that if the products are exposed as they would be to real life weathering, and then there is a fire after a period of time in use, the product is still going to work and it's not going to be negatively affected by that weather. So these are the critical things that are key for fitness for purpose for products in the market, not hardness. Hardness is just as an indication for when the product is ready to go into service.
And so, what I'm thinking now is that as long as this, I don't know what you want to call it, this habit or this tradition of 70 being somehow the number that matters, as long as the industry continues to follow that or continues to believe in its power, it is kind of selecting itself out of a wider range of materials they could choose from, which could have some, beneficial properties either during application or in service, potentially selecting themselves out of cost savings or constructibility concerns. Is that the case?
That's 100%. I think it is highlighting one particular physical property of the coating and placing too much importance on that particular one, whereas there are a lot of other unique selling points for many different products out there that are far more important, valuable to the contractor, valuable to the applicator, valuable to the owner, architect, rather than just the hardness.
I want to talk about recovery. Does that refer to a material can bounce back and take its original shape after it's been compressed somehow, or like say it's been hoisted up by straps or on a forklift or something?
Yeah, that's exactly it. So it's the elasticity in a coating rather than just simply being displaced. In the example that you give about hoisted with straps on a forklift truck, with some coatings, it might be that it's simply squashed out from underneath those straps by the weight of whatever is being lifted. Recovery would be the elasticity to be able to jump back into the original shape or form.
Does that matter in terms of reaction to fire? Let's say if something is smushed down and doesn't recover, does that somehow limit its ability to do what it's supposed to do?
I think it can do if it's smushed down to an extent where there is insufficient cover on that particular part, because the intumescent fire protection is tested and certified in a way that for that particular piece of steel, a certain thickness of coating is needed for a specific time of fire protection. If the coating is deformed in any way, shape, or form, if it is you've got under coverage in that area, then you might not necessarily have the required and necessary amount of protection in place.
And so we have the material technology has advanced to the point where we have these products out there that do recover better than others. It makes me wonder if there's a level of forgiveness there. Not saying that you shouldn't take care when you're transporting your material or transporting your steel, but it's an extra level of assurance, maybe.
Yeah, I think so. And this is where we would highlight this as damage resistance, because what we do see with coatings that are very hard or that have a high number on the Shore D scale could be quite brittle. So if there is an impact, then it can spread wider than just the impact zone. So it might delaminate, for example. Whereas if we have coatings that are a bit more elastomeric and do give a little to the weight and the pressure, then any damage is minimized or even eliminated.
Let's say we have an opportunity to just wave a magic wand and change what specs say, or maybe go beyond that and also change what people know or what people understand. But what do you think is the proper, at least as far as documentation goes? Are we saying Shore A and Shore D should exist side by side? Are we saying that these shouldn't be there at all? How do we reconcile?
I think they should exist side by side. I don't think that they should be used on specifications to differentiate between one product or another. I think that they should be used for quality purposes so that we know exactly when the coatings have reached ultimate hardness or cure level or drying, whatever we want to term that. But then those numbers are specific to the product that has been selected. And I think that the products should be selected on other things, as you mentioned earlier, about the ease of application, the fire certification that it has, all of those other properties, but not necessarily hardness.
We have four very important questions now that we get to ask Michael because it's the Red Bucket, and the Red Bucket always has four questions at the end. So, what is the most interesting job site you've ever visited? And in 32 years, I'm sure you've seen quite a number of them.
Um, yeah, good question. I think the most interesting one, I think, was where we had a complaint, actually, that our coating was blistering on application. And we put several different possibilities to the customer. One being that they'd applied too much thinner to the coating, and it was skinning over at the surface, and then the thinner was being trapped inside and blistering. And they denied everything and insisted on a site visit. So this involved a 4 hour flight and then a 3 hour drive to get there. And within the first 5 minutes, we'd identified that they'd just thrown in a huge amount of thinners into the coating and completely destroyed the product. So that was a really long day and trip to really fix something that could have been identified over a Zoom call or something.
That's like those meetings you have at work, and then you leave it thinking that could have been an email. This would have been fine if it was in an email.
Yep, exactly.
Where's the best vacation destination that you've ever been to?
That's a very good question, Toby. I like the Greek island of Rhodes and also Istanbul in Turkey because there is just a lot of history to go and see there. But I also like Asia as well. It's just excellent food, really friendly people, and lots to do and see.
So where do you recommend?
Istanbul, I would recommend. Just so much history to go and see.
How about in Asia?
In Asia, there's no bad places. I think I like Hong Kong, Singapore if you've got plenty of money. Vietnam if you don't have plenty of money, but also Thailand is really nice, and Malaysia as well.
You got a favorite hobby?
Snooker. I play snooker. So me and my brother-in-law play quite regularly, and he's getting a bit better. So I'm running the risk of he might actually beat me at some point. So I need to up my game.
Go hit his hand with a hammer or something.
Exactly.
What? Tell us Americans what snooker is.
So snooker is, I guess, a little bit like a pool or billiards, but the table is a lot bigger. So it's 12 foot by 6 foot, and the balls are smaller, and then you have 15 red balls and 6 colors, and you have to put them in order. So it's a red color, red color, red color. And then the colors keep coming back out until there's only the colors left on the table at the end, and then you have to pot those in sequence. So the maximum that you can get is 147, and the most I've ever had is 57. So I'm nowhere near the maximum. But the World Championships is in May, and there is one guy that's been best in the world for a hell of a long time, and he holds the record for clearing all those balls in under 6 minutes, and no one has ever come close to that again.
I was thinking as you were describing how it goes, that those must take long. A game must take a long time.
It can be. It depends who you're playing, and also just how you're playing as well. So, I've played for a few teams, and I think I'm not a bad player. But when I've had a match game against one guy in particular, I remember I was in good form. He was in excellent form, and we finished the whole game in less than 8 minutes.
Oh, wow.
Yeah, but then
Okay.
I have been involved in some real long ones where you're talking an hour and a half.
I was going to say, I've never played it, and I feel like if I did, I'd have to bring a sandwich with me because we'd be playing that long. Final question, Michael. As an Englishman who has been to the States, it was nice to see you when you were here the last time, by the way. What is the best American food you've had, and what's the worst American food you've had?
Oh, I think the best, I like gumbo and jambalaya. So those would be a couple of my favorites. And I think the worst one is deep fried pickles. I just don't understand that.
I had some when the Super Bowl was on just last week. We had some fried pickles. I don't know if I'm not gonna go so far as to disagree with you and say that actually they're great, because I don't think they're great. But I think that's just the yank in me. Like, we'll throw it in some hot oil, and just, no matter what it is, I guess in our minds we think that's okay, because we'll do that to like ice cream and cookies too, which I don't get that.
Yeah, we have that in UK, particularly in Scotland as well, where they will deep fry anything. So pizza, they will dip it in batter and then deep fry it. Pizza, a Snickers bar, things like that. So it's quite famous. But then again, the mortality rate is a lot lower in Scotland than it is anywhere else.
I guess they've got something figured out.
Yeah.
Michael, this has been great. Thank you for sharing your expertise with us today. Let's talk again soon.
Appreciate it. Enjoyed it.